Hi guys, it's Ben Bidoff here from the Department of Primary Industries and Regional Development. Welcome to the webinar series. This is the third topic in the series. Today we have Brenton Lesk, who's a research officer in the Department of Agriculture, talking about sowing time in frost-prone environments. Brenton came to the department 3.5 years ago as part of a graduate recruitment program and has been working on frost within my R&D team for the last 3 years, but he's currently on study leave at UWA and he started his PhD over there in July this year, but he's just going to give us a quick run through of some of the work he's been doing over the last couple of years with us while he's been here at the department. Thank you, Brenton.
Thanks, Ben, for that introduction, and welcome to everyone who's listening in the room here with me and online. So this work is, I'll be going over some work that we've done over the last few years now, and this comes from a paper that we wrote for the Agronomy Conference. There's a number of people involved in this project. I'll acknowledge them at the end, but here at the department, this work was done collaboratively with Ben and Dion. So a bit of background about frost in Western Australia. Some of you would be aware, and for those who don't, that last year was a particularly severe year for frost in WA. Estimates from GIWA put it at about 1.64 million tonnes, so that's the difference between the production forecast for wheat in August and then at the end of the season, and at a wheat price of $250 per tonne, that cost the industry estimated around $410 million. But also there's the effect that frost can have on growers and their strategy to how they run their cropping program, and it can drive them to sort of sow later in the season to avoid frost, and also drive conservative inputs into their crops in the following years. However, there are a number of strategies available to growers to manage frost, and these have been outlined in GRDC's frost tips and tactics. But one of the major ones that they can use is time of sowing to manage this risk. So some of the key findings from 2 years of trials looking at time of sowing and frost have shown that in both years there was no optimal window to avoid frost. Frost occurred right through the flowering window. However, there were optimal sowing times for wheat maturity classes to maximise grain yield. So this is a map here showing where the trials were located. So we've got Perth here. They were located probably about 1.5 to 2 hours from Perth. So this pin here is at the 2016 site at Dale, which is shown in this insert here. And then in 2015, the trial was located 30 kilometres east of Brookton. And both those, there was about 60 kilometres between those trial sites, and both those trials were located in frost-prone valleys. One at Brookton on a west-facing slope, and one at Dale in the bottom of a valley in the Avon catchment. So this is the results from 2015 at Brookton. So we've got grain yield here on the left y-axis, we've got flowering date across the bottom, and canopy air temperature on the right y-axis. So all these points here on the graph are the predicted means for each variety in the times of sowing, noted by the colours across the top. So they were sown from the 15th of April and spread 7 to 10 days apart right through to the 22nd of June. Now the bars, the blue bars are the frost events. So you've got the zero line halfway along this right axis here. So these are the frost events that occurred throughout this flowering window with canopy temperatures below zero. And then the red bars are what are called heat events, so they're temperatures greater than 30 degrees Celsius, and they're being divided by a factor of 10 to fit on this axis. So you'll notice that there were frost events right throughout where all these varieties were flowering in the trial, and some heat events throughout the end. However, there's a peak in yield for these varieties, which is around first week to the third week of September, where yield is maximised. However, there's still a lot of frost around this time. So if we take some different maturities here, so selected Axe, which is a fast wheat maturity or has a short time to flower, Mace, which most of you are familiar with, and Magenta, which is a mid-long variety, so it flowers a bit later than Mace. Yippee, which is a photoperiod responsive variety, responds to longer days, so it's similar to the new AGT Cutlass that's out now, and Weiler, which is a winter wheat. And so these have been plotted on the same axes as before with grain yield and flowering date. And you'll notice again that there's this period where yields peak, and that's during the most frequent frost period, but ideally you want your varieties to flower sort of during this window where the yield is maximised. However, during the season you don't know what sort of seasonal temperatures that you'll get at sowing time. If we put them in terms of sowing date, you can see that the yields for the winter wheat Weiler here in the black, they were most suited for, it was best suited for April sowings, so from mid-April through to last week of April, around Anzac Day. And then you've got Yippee in red here, that was suited for first week of May. And then Magenta, yield started to pick up until the middle of May, and then Mace came in and performed quite well, and this sort of response that you see here towards the end is common what you see in MVT with Mace, so yielding quite well when most MVT is sown around this this middle of May point for the central weaker. So in 2016 we ran a similar trial to see, and we're interested to see whether this response was consistent between the years. So this is an aerial shot of the trial, so you've got sowing banks running from the 15th of April right through to the 22nd of June on the left here. And we use irrigation to ensure that the crop establishes on the same day that it's sown. Now, 2016, as mentioned at the start, there was a lot of frost and the growing season was quite cold. And this figure shows time across the bottom here and what we call thermal accumulation or thermal time. So that's the difference between your maximum and minimum throughout the day. And what it's showing is this red line here is 2016 and how temperature tracked compared to all the other years in this database, and the blue line's average. So below this blue line means the season was colder, and so that coldness affects the time to flower for the varieties in that season. So it means that they flower later and accumulate biomass a bit slower, but also reduces evaporation of water throughout the growing season, so they're better able to use that. So this is the 2016 yield results and how they came out. Now you'll notice from the previous figure from 2015 that this slope is a bit steeper And for early sowing, there was a greater yield penalty due to frost, so yields are a tonne or lower for early sowing from the 20th and 27th of April sowings for the different maturities that we had in the trial. And then those yields start to pick up and then drop back off. If we overlay the temperature across that, you'll see there are a lot of frost events running right through that flowering window, and then a few heat events towards the end. So if we take that in terms of those same 5 spring wheat varieties, 4 spring wheat varieties and 1 winter wheat variety, Weiler in the black. Again, there's a penalty for sowing early. Quite low yields. They peaked and then dropped off. But you've got frost events right through this flowering window with just this little gap here of 1 week, where they might have avoided a flowering frost, but there would have been grain frost after they flowered, and also booting or heading frost damage earlier. So again, looking at that sowing date interaction with grain yield for those same varieties for 2016, the winter wheat varieties were suited again to April sowing, and there was a lot more frost damage and lower yields for early sowing of other varieties with shorter maturities, Mason, Magenta and Yippee, and then they start to pick up again from the first week of May, peak around mid-May, and then starts to decline. So to summarise these 2 years of results, in frost-prone environments in the central wheat belt of WA, the winter wheats were suited to April sowing, and this result's consistent with some work done by James Hunt, who had some trials in WA in 2015 at Cunderdin. And you'll notice in this previous figure that there is quite a large difference in the yield potential between sowing a winter wheat early in a frost-prone environment compared to sowing any of the other sort of maturities. I'll touch on that in the next slide. The longs, so Yippee and Cutlass, were suited to early May and mid-May planting. The mids, so Mason Scepter, was suited to mid-May planting, and short maturity wheats, so Axe, Westona, Emu Rock types, they were best adapted for June planting. Back to that difference in yield potential between your winter wheats and long maturity, sowing them early, and maize. If you manage your varieties based on when the optimal sowing time is, or use, say, 3 wheat varieties instead of just sowing all maize, you had a gross income of $195 per hectare and $433 per hectare in 2015 and 16, compared to sowing just maize over your whole program, or a single variety of that sort of maturity, assuming $250 per tonne per week. So that brings us towards the end of the presentation. A few acknowledgements. I'd like to acknowledge the National Frost Initiative and GRDC for their support, DAFWA as well, and the technical support there as well, trial hosts, Living Farm for managing the trials, and SAGI for their statistical support. So to summarise, the take-home messages for these 2 trials for frost-prone environments were that there were no optimal flowering window to avoid frost that we could find in these trials. However, there were optimal sowing times for wheat maturity classes to maximise their grain yield and your gross income. Thank you.
Thanks, Brenton. Well thought out presentation. Now, we have had a few questions come through during the time. If anyone else has any more questions that they would like to ask, can you please type them up now, and I'll briefly read out some of those. So before I go to the questions that are on there, are there any questions from the room here? Yeah. Okay, so Brenton, one of the questions is, in terms of variety mixes, how do growers choose a variety mix to maximise their production across the whole program? So your data showing that in some areas there is a big opportunity cost, but obviously farmers have to manage the whole sowing program and the whole sowing window. How do they manage that? Or do you have any ideas of how growers can manage that in their production system?
Well, a lot of growers now are starting to sow or have been sowing on calendar dates. So that makes selecting varieties in their sowing program a bit easier. So this work shows that if you're wanting to start seeding on the 15th of April or even Anzac Day, you should select winter maturity types at the start of your program, and then start switching once you've sown those to longer maturity types, so maybe Yippee, Cutlass, then move on to Magenta or similar maturities, and then on to Mason Scepter, and sort of work through those throughout that program.
Yeah. And if we then have a late break like we had in 2014 or 15, where we had intermittent starts to the season and they don't get their winters up in that early May, what's the loss from that?
Well, we've got a couple of figures here. So this is looking at gross income for Brookton in 2015, so a late break. So if you were to sow Weiler, and it came up on the 15th of May, so that was when your late rains came. The grain yield came out to be 2.8 tonnes per hectare compared to maize, so it was pretty comparative. And then if it came up on the 23rd of May, you got 200 kilos there. So there was only a 3% decrease in gross income by sowing a winter wheat in mid-April, and then coming up sort of mid to late May. I suppose one consideration around that is your weed control. So you want to be sowing these winter wheats into paddocks that are clean. Otherwise you could have a lot of weeds to deal with later on in the season.
Yeah.
And similarly for 2016 in Dale, there was actually a positive benefit still in putting a winter wheat in compared to maize. But that was, I suppose, a standout year in terms of the frost severity for early sowing for maturity types like maize.
Yeah. Okay, thank you. So, I mean, I guess your key take-home message is the winter wheats give us the opportunity to explore that early sowing window, and there's a big potential in terms of improved grain yields over spring wheats in that window. But if we are still sowing our wheats in the later window, then we need to stick to the main season wheats. So it just really depends on how growers want to manage that risk in terms of their sowing window. If they want to go early, then the winter wheats are a viable option, and there doesn't seem to be much yield penalty in that central production zone when we do have a late break, but there's a big upside when we do have a good season. Yeah. Okay, thank you. Thanks a lot, Brenton, for your presentation today. I haven't had any more questions come through, so I'll give everyone another couple of minutes. If there's a quick question you want to type through and send through, that would be great. Otherwise, are there any questions from the room? Okay, thank you, Brenton. All right, so I still have not received any questions typed up. So thanks a lot for all our attendees who have dialed in today. If you do have, or if you want more information, you can still contact Brenton himself directly, or you can have a link through to a couple of papers that he talked about at the agronomy conference paper, or the Perth Crop Updates website from 2015 or 2017 Perth Crop Updates papers. Thank you.